Let us continue with the chapter 1, application of matrices and determinants, exercise 1.1. Now let us see second sum in that. Here the second sum is find the inverse if it exists of the following. First sum, it's a 2 into 2 matrix. Here the question is find the inverse if it exists. Note this point. That is why they say that if it exists. First we should see whether inverse can be found or not. Whether inverse exists or not. A is non-singular matrix, A inverse exists. If it is a singular matrix, A inverse does not exist. What is singular, non-singular? Non-singular, the determinant value of the matrix is equal to 0 means it is singular, not equal to 0 means non-singular. Let's see what A is equal to the matrix now the determinant value, it should be tested. Determinant you put 2 bars. Matrix we use brackets. So the value of this now, just multiply the opposite, that is 6 minus 4, that is 2, and that is not equal to 0. 6 minus 4 is equal to 2 and that is not equal to 0. So A is non-singular. Since A is non-singular, A inverse exists. So for inverse, we have to first find whether it is singular or non-singular. Not equal to 0 means non-singular. Now we'll go to the inverse formula. A inverse, A to the power of minus 1. 1 by determinant A into adjoint A. Our point is now find adjoint A. That is for 2 into 2 matrix, just invert the leading diagonal and the symbol of the other diagonal should be changed. This is adjoint A. Leading diagonal is the first row, first column. That element is called the leading diagonal, that diagonal. Therefore, now A inverse is equal to 1 by the determinant value. The determinant value was 2, we saw it before, and then this adjoint should be written at the side. That's over for this first. Let us see the next sum. This will be 3 into 3 matrix. So let A be equal to the given matrix. Now this is 3 into 3 matrix. We have to find the determinant value of this matrix. That is determinant of A. By expanding this determinant, we find the values. You would have seen in your previous year classes, expansion of the determinant. First row, first element, and then within the bracket the other determinant values 5115. Expanding through the first row, the second place will carry the value minus, so it is -1. So we have expanded the determinant through the first row. So find the values now. Multiply, subtract the other diagonal. The value of the matrix is 112 and that is not equal to 0. So this is a non-singular matrix. If the value of the determinant is 0, just stop the sum. This is a singular matrix, inverse doesn't exist. Here this is not equal to 0. Here since A is non-singular. This line is very important, should be mentioned in your exam. A inverse exists. This line is important. You are telling your point, stressing that A is non-singular. So A inverse exists. So now we are going to the formula, inverse formula. You know the inverse formula. Again I will remind you, it is A inverse is equal to 1 by determinant A into adjoint A. So finding inverse, we have determinant value, we have found out. So we have to go to this term, adjoint A. Now find the value of adjoint A. Adjoint A, we know the cofactor matrix, transpose of the cofactor matrices. Cofactor of the first row, first element. Cofactor of the first row, second element. Cofactor of the first row, third element. Similarly, the others. This is cofactor matrix, the transpose of this. Second row, sorry, it should be minus. Now find the value and the transpose of this matrix. So transpose is just the first row should be changed to first column. Second row into second column, third row into third column. Now taking 4 common from every entry. Therefore, now finally we are finalizing the answer. A inverse is equal to 1 by determinant A into adjoint A. So just substitute the answers we get. Now A inverse is equal to 1 by determinant value into, now since it is divisible by 4, you can reduce the number. It can be reduced. 4 will go 2 times and then 4 will go 8 times. So it is 28. So we now saw 2 into 2 matrix and then 3 into 3 matrix. In this second sum, you have another sum 3 into 3 matrix. You can try this in the same manner. So next video, let us see with the third sum of the same exercise 1.1. Thank you. Enjoy.